Welcome. So, if you're into programming, you know the list of languages just keeps growing. It can feel like a lot. So, why are there so many? Today, we're going to crack open the programmer's toolbox and figure out what all these different tools are really for.
Seriously, if you've ever even just looked at coding, you've probably asked yourself this. You hear about C, Python, Java, SQL, R. I mean, the list is just endless, and honestly, it's overwhelming. You start to wonder, are they all just different ways of doing the same thing? And the answer is, well, kinda yes and kinda no.
Okay, so here's the secret to making sense of it all. The best way to think about this is to stop calling them languages for a second and start calling them tools. Imagine a programmer has this big toolbox. Just like a carpenter or a mechanic, they can't use a hammer for every single task. They've got to have the right tool for the right job.
All right, let's look inside this toolbox. First up, we've got the all-rounders. These are your foundational tools, the ones you can grab for a huge range of different projects.
So, what's a general-purpose language? Well, the name kind of gives it away, right? It's a jack of all trades. These are your hammers, your screwdrivers, your adjustable wrenches. They're designed from the ground up to be super versatile, so you can build almost anything you can dream up with them.
So, what makes them so flexible? Well, it all comes down to the basics. At its core, a computer does two things. It stores stuff, we call those variables, and it follows a list of instructions. General-purpose languages are built to work directly with that fundamental design. That's why you see languages like C or Pascal being used for, well, everything. From the operating system on your computer to desktop apps, even video games.
But, a hammer isn't always the right tool. Sometimes you need something with way more precision, right? Like a surgical scalpel. So let's reach into the other side of our toolbox and pull out the specialist tools.
And this really gets to the heart of it. What happens when you have a really specific job to do? I'm not talking about building a standard website. I mean, what if you have to crunch some seriously complex scientific numbers or process millions of financial records for a huge bank? Trying to use a general-purpose language for that, well, it can feel like you're trying to perform surgery with a butter knife. It's just not the right tool.
So for those heavy-duty scientific calculations, the early programmers realized they needed something custom-built, and that's exactly where Fortran comes into the picture. It was one of the very first high-level languages designed for one very specific, very demanding job.
And Fortran is a perfect example of why specialization is so powerful. You can think of it as a superpowered calculator built just for scientists. Everything about it was designed to be screaming fast and ridiculously accurate with complex math, especially for handling huge chunks of data like arrays and matrices.
Okay, so that's the science world. Now let's completely switch gears. What about the world of business? Managing inventory, processing orders, that requires a totally different kind of specialized tool.
And that tool has a name: COBOL. It was basically designed to be the ultimate digital ledger for businesses. It's amazing at stuff like generating reports and handling inventory. But its real superpower? It's all about handling decimal numbers with perfect precision. See, when you're dealing with money, even a tiny rounding error can snowball into a massive problem. COBOL was built from the ground up to make sure that never happens.
And this idea of specialization isn't just for data on a computer screen. Nope, it actually extends out into the real physical world. I mean, think about it. How do you tell a giant, complex industrial robot what to do with precision?
Well, you use a special language for that too, like APT. That stands for Automatically Programmed Tool. And the list of these specialists just keeps going. You've got RPG for business reports, Prolog for natural language processing. The big takeaway here is that for pretty much any unique, specific problem you can imagine, someone has probably built a specialized tool that can solve it way better than a general one.
Okay, so this brings us to the ultimate question, right? With all these different tools in the toolbox, how does a programmer decide? Do you go for the flexible all-arounder or the powerful specialist? Well, it all boils down to a classic trade-off. And this table just lays it all out perfectly. With a general-purpose language, your key advantage is flexibility. You can do almost anything. But with a special-purpose language, you get incredible power and efficiency, but only for its one specific job. That's the trade-off, right there. You're swapping that do-anything versatility for laser-focused power.
The source material for this explainer puts it perfectly. It says, the appropriate language to use often depends on the application domain for the problem to be solved. And that's really it. It sounds simple, but that is the absolute core principle behind choosing a programming language.
So at the end of the day, it's not about finding the best programming language.
That's like asking what the best tool is in a toolbox. There's no such thing. There's only the right tool for the job you have in front of you. And that should hopefully give you a whole new lens to see this stuff through. So the next time you hear about some hot new programming language, instead of asking, is it any good, try asking a different question. Ask, what's this tool for? What specific problem was it designed to solve?